So with the tide, whenever you're talking about waves and tide, we're going to start by, I like to plot the information that we have, so then we get a good idea of what the graph's going to look like. So high tide, the highest point it ever reaches, and that happens at 10:46 a.m. Then, and at that time they found it was 9 feet. Then at 4:58 p.m., it was low tide and it was only 4 feet. So 4:58, which is 6 hours and 12 minutes later, it was at the lowest point, which is only 4 feet. So since this is a sinusoid, looks something like that, but a little bit better than what I just did. And it'll end back up at high tide. High tide, if that took 6 hours and 12 minutes, it would take another 6 hours and 12 minutes. We don't really care about that, though. The depth of the sinusoidal function, time with a period of half a lunar day. So that makes sense. That is 12 hours and 24 minutes because it took 6 hours and 12 minutes to get halfway. You got from top to bottom in 6:12. It will take 12:24 to get back up all the way from high tide back to high tide. So, a few things that you need from this. The highest and the lowest point, very, very important, so that you can find the amplitude. And all of that's going to be based off of this midline, which will be right in the middle of 9 and 4. So we need to come up with what our midline is so we can get that into our equation, and then we'll also use the amplitude. So the middle of 9 and 4, 6.5. And then if the middle is 6.5, that means you have 2.5 to reach the 4 feet, and 2.5 up, you would reach 9 feet. So that means the amplitude is 2.5. So the midline is 6.5. The amplitude is 2.5. This is a cosine function. So, can I erase some of this because we don't need it all? The basic form that we're using for a cosine graph is y equals a cosine where a represents the amplitude, 2.5. It is cosine because it starts at the top and then goes down. Sine would start at the middle and then go up and down. B has to do with the period. Period equals 2 pi over b. We know the period is 12 hours and 24 minutes. We have to solve for b, so it's going to solve that out. So 24 minutes out of an entire hour is 24. So the period is 12.4 hours. If you solve that for b, you would end up getting b times 12.4 equals 2 pi, which is going to lead you to b equals 2 pi divided by 12.4, or reduce that to be pi over 6.2. So b, pi over 6.2. And then that's x minus whatever our horizontal shift is. It's shifted to the right to 1046, which is 46 out of 60 minutes. That's a strange decimal. So 10.7666 repeating. So plus d, which is our vertical shift, which is to our midline, 6.5. So there's the sinusoidal equation function. You can type that into the calculator. So I'm going to go ahead and add 10 onto this. I'll store it as C because I don't want to retype that whole thing. So now when I'm typing this out, I can just say x minus c, and it'll work out. So go to our graph. .5 cosine. B was pi over 6.2. Make sure you have that fraction in its own parentheses. Times x minus, stored it as c, so I don't need to type it. Plus our vertical shift, which went up to 6.5. So before I graph it, I'm going to go to, okay, there we go. Check what I'm in. I'm going to want this to be in radians. I know that because there's a pi in here, which is always going to be radians. We don't use pi with degrees. And we need to change our window. X was time, so we can have it go from 0, which will be like midnight, to 24 hours later, because that's how long a day is. Our Y minimum, that's okay to be 0 because the lowest point the tide goes is 4. The highest it goes up to is 9, so let's have that go up to like 10 in our window so we can see it. And there's our beautiful graph. What's the approximate depth at 7 a.m. and 9 p.m.? 7 a.m. is 7 hours. 9 p.m. is 9 hours plus 12 hours because it's after noon. So that'll be 9 plus 12, 21. So that's at t equals 7 and t equals 21. So we're going to just go trace. We want to know what it is at 7. And the depth is 5.671. That's feet with the units of measurement. And then at 9 p.m., that would be 21 hours. So we'll type in 21. 7.639. And then what's the first time on Father's Day that the depth is at 8 feet? So now we're going to do a G-solve. We know the depth, which is y, so we're going to do an x-calc. And we know the first time that it's 8 feet. I think that's what it said. So it happens almost right away. Happens at 0.1967 hours after midnight. 0.1967 hours into the day. That's not very helpful, because that's not minutes, that's decimal of an hour. So with that saved in, we're going to keep it right there as X. We're going to go back to our menu. X is the 0.1967, that's fine. That's what we want, but we want to know how many minutes is that. So multiply it by how many minutes are in an hour. Multiply it by 60. And it'd be about 11, almost 12 minutes. Almost 12 minutes into the day, which means the day starts at 12 a.m. at midnight, about 12 minutes in. It's right before 12:12 a.m.